Hello, Professor. My name is Kondapalli Saiteja, and today I am talking about a research article from Usenix called "The Gates of Time: Improving Cache Attacks with Transient Execution." This article is proposed in 2023 by five authors from three different universities, and they have worked together to improve the security of the computer system. In this article, it is mentioned about several topics called cache attacks and transient execution, and logical gates are also introduced in this, which is used for amplification purpose. And there are implementations like arithmetic logic unit and Conway's game of life is also described in this article. And the main aim is about the cache attacks and the importance of the transient function used in this cache attacks. It is also described about the manipulating cache states by implementing the logical gates. There is a method called amplification which is used in this research to increase the time difference between tasks, and a high resolution timer is used to catch these cache attacks. And with the help of this amplification, we only use low resolution timers, and this work presents a significant improvement in computer security, and the design implementation is also made easier. And in this cache attacks, the cache is defined as a small component of the memory which is located at the processor, and it is responsible for managing the data which is assigned to the processor. It also acts as a medium between the processor and the memory. There are two methods that describes these cache attacks. When the processor accesses the memory, it has to make sure whether the line is available in the cache or not. If the line is found, then it is called cache hit, and if the line is not in the cache, it's called cache miss. During cache hit, the memory access is provided to the requested line, and in cache miss, the line has been removed from the main memory and stored in the cache for future use. There are different levels in this cache based on speed and performance, which are L1, L2, and L3. Here, L1 cache is the smallest and fastest among three, and L3 cache is the slowest and consists of large capacity of storage, which is shared between the processors. In this cache, each line is separately mapped to a single cache set and should be stored in the same set. When multiple memory addresses are mapped to the same cache set, then they are congruent to each other. We combine these congruent memory addresses together to form an eviction set. It is also mentioned about a cache attack technique called prime probe. It makes the security vulnerable and disturbs the structure of set associative caches, which leads to the leak of information. Transient execution. Transient functions are useful in performing manipulations in arbitrary functions of the cache state. In these functions, mainly the operations are done using logic gates where inputs and outputs are stored in the memory address of the cache states. It mainly highlights the utilization of transient execution which improved the cache attacks. It modifies the arbitrary functions which are available in the system, and in these operations logic gates have been used by the authors, and memory address of the cache states are considered as inputs and outputs to these logic gates. There are several processors where logic gates can be implemented like Intel, AMD, Apple, Samsung, etc. By using this transient execution technique, we can manipulate the cache states and amplify it to store the information of the cache present in the processor. It also processes the information and performs high resolution cache attacks by using only low resolution timers. The designing of these gates is based on the logical value of the memory address. When an instruction is reading from a memory address or writing to a memory address of the cache, then the logical value is set to 1, and when the instruction is removed from the memory address, then the logical value is set to 0. Logical gates. In this research, logical gates are used for computing process. Here, the logical values of uncached address are defined to 0 and cached address are defined to 1. It is easy to change the state of cache as the data is read from the memory address and fetched directly into the cache. Then the logical state is changed from 0 to 1. The only drawback is that we cannot use the same address as input into multiple gates. As we have mentioned, it has used several speculative windows to create a NOT gate. The designing principle is based on the time taken by the processor to evaluate the mispredicted branch. The length of the speculative window depends on the number of instructions which is executed after the branch. Before using the gate, the branch predictor needs to assume that the instruction is not 0. Then the processor consequently executes the instructions from the predicted branch. To create an AND gate, we need to operate an instruction of a NOT gate by replacing it with an if instruction. Similar to the NOT gate, branch predictor needs to be trained before the speculative execution is opened. Then the CPU processes both the instructions simultaneously, which would have increased the length of a speculative window. If any of the input address are uncached, then the processor needs to wait until the data is recovered from the memory, which also results in a long speculative window. Branch training. Branch training is a technique that is used to make sure that the branch predictor is assumed according to the requirements of data. It depends on the It assumes either a logical value which is 0 or 1. Sometimes these branch predictors assume incorrect values due to the failure of the executing several operations. Branch prediction is mainly used to avoid stalling in the process whenever there is a branch condition that needs to be processed. Whenever any branch is mispredicted, it consists of several operations which are not able to execute, and also the recently executed branches and the instructions are issued depending on the branch prediction. If it predicts correctly, it saves a lot of time by allowing the next instruction to execute, and whenever the prediction is wrong, the processor deletes all the executed instructions and front end needs to repeat the process again. These deleted instructions which are recently executed are called transient instructions. The gates are divided into two types and being used in this research which are based on the branch delay, and the gates without branch delay are also introduced in this research. Generally, the operations in the gates is mainly based on the time taken by the processor to resolve any operation and the time the outputs are accessed. There is an example of buffer gate where it calculates the square root of operations which are set to 0. During this process, the processor predicts the outcome of the branch, which in turn predicts the output, and the processor executes the remaining code. In gates without branch training, the first two instructions are trying to be mispredicted, which are called dry runs, and the instruction predicts the correct one later, which is called the wet run. Due to this, the runtime of the gates is increased and the speed of the process is decreased. To increase the speed of process, we use branch predictor to mispredict the branch, and the processor should not repeat the entire process again where the where the branch predictor is mispredicted, so that it saves a lot of training time and reduces also reduces the errors in the process, which in turn allows the process to be faster. Amplification technique. As we know that amplification is a process to amplify the cache states so that the time difference between two cases is more than 100 milliseconds. By this, we make sure that whether the specified memory address is cached or not. With the help of this technique, we can create eviction sets by using low resolution timers in WebAssembly. To implement this amplification technique, there are three types of circuits which we use. The arithmetic logic unit, SHA-1 hash function, and Conway's games of life. Here, speculative gates and cache states are load sensitive, which makes the process vulnerable when large data is processed. The effects of CPU frequency is also measured, by which we know that processor executes mostly at high frequency. The results are based on the frequency of the CPU. Here, these amplification techniques are mainly used speculative gates to enhance the detection of the cache states. Especially when high resolution timers are restricted, we use this amplification technique so that the time difference is measured using only low resolution timers. ALU implementation. ALU is also known as arithmetic logic unit, and in this research, the construction of 4-bit ALU is adapted from Nissan and Shoken. As we know, the input of this ALU consists of two 4-bit numbers and six control values, and it produces an output of 4-bit value, and these control values instructs the operands to perform on a specific operand. With the help of these construct values, the ALU has performed many operations like increment, decrement, addition, subtraction, negation, etc. There are several error correction techniques which have been used to improve the accuracy of ALU, and we run these ALU 5 times by using the same initial values in 5 different copies. The majority of these values is considered as the final output value, and this majority voting method is defined as a classic error correction technique by the authors in this research. It is also mentioned that 10,000 sets of experiments are done in this research to measure the performance of ALU, and the correctness of the output is found almost 9,800 experiments. In each set of runs, there are 100 runs which inputs are selected randomly, and all the 4 bits in a run is correct, then the accuracy is determined as 1. Whenever there is at least one of the 4 bits is incorrect, then the accuracy is determined as 0. Thus, by using these experiments, the performance of the ALU is measured. Game of life simulation is a technique which is used by the authors, and in this Conway's game of life simulation, the game is considered as a cellular automation that consists of a grid of cells, and these grid and in each and every cell is determined by its state, whether it is dead or alive, and the state of the cell is assigned based on the values of its cell along with its eight neighbors. A live cell consists of two or three live neighbors which should remain live throughout the process, and a dead cell should have exactly three live neighbors that should become alive, and all the other cells which are present in the live cells and dead cells should remain dead. We determine a live cell, a state of cell, by whether it is live or dead by using the logical value, and each live cell is determined by 1 and each dead cell is determined by 0. The next state of the cell should be calculated, and it should evaluate the state of that particular cell along with its 8 neighbors, and during this evaluation the value of the cell changes, and it is crucial to not to destroy the state of each cell, which should be referenced as a future purpose. To overcome this error, it stores the value of the cell in two different locations, where one is used for the actual process and the other cell is used for the future reference. And in this Conway's game of life simulation, the state of each cell is responsible for the processing and implementation of this technique. Probe amplification is a technique where we use logic gates for side amplification, which is necessary in speculative execution, and it is also used to determine whether the cache line is cached or not. When the time difference is less than 100 clock cycles, the process requires high resolution timers to access. And in this, instead of using these high resolution timers, we use amplification technique to amplify the time difference between each cache hit and cache miss. Here, in return, allows low resolution timers to differentiate between cache hit and cache miss. There are three steps that are mentioned in this article, and the first step is use fu- and the first step we use a single gate which results in a simple amplification method, and in the second step we use a tree-like structure that achieves a time difference of up to 4 milliseconds, and in the final step we use a multiple trees to form a hypertree-like structure which achieves an arbitrary long timing difference in between each cache hit and cache miss. In the hypertree amplification process, we test the code using several platforms like native code, WebAssembly, and these experiments are conducted on Dynabook Tegra A50EC, which consists of an Intel Core CPU. We also use Chromium 99.0.4843.0 processor to test the WebAssembly code, where the hypertree structure mainly consists of three layers. In this hypertree structure, the top layer is amplification free from 1 to 16 bits, and the bottom two layers are the amplification trees from 1 to 512 bits. We can also use this hypertree amplification process to create the eviction sets with the help of low resolution timers, and these low resolution timers are available in the browsers like JavaScript and WebAssembly. So by this probe amplification method, we use low resolution timers to prime store. There are two issues that have been mentioned by the authors in this research using slow clocks. The first one is that it is hard to differentiate between two events, and the second one is that the clock limits the rate to measure these events. It takes at least one clock tick for each measurement. Prime store is considered as a variant of prime probe, and the design implementation is similar to the prime probe, where it uses NAND gate and eviction set as input. The out the result of this prime probe is stored in the cache state of the output, and whenever we need to perform multiple processes for the same cache set, we use the same NAND gate and the eviction set that is present as input, and each output which is stored in different memory address, and this allows the process to repeat the samples at higher rates. And to demonstrate the performance of prime store process, it should recover the private key from Elgamal public key encryption. It is known as vulnerable, and it consists of three steps. At first, it should collect the data of the activity of the memory where the segment has undergone the modular exponential operation. In the second step, it performs the operation to recover the segments, and in the final step, the private key should be recovered by combining all these segments together. It is also mentioned that the setup of the attack and the victim of the attack is present in the subsection of this process. To conclude that this research is mainly based on using transient execution to improve the cache attacks, and they used a lot of different types of logical gates to determine the state of each cache. The amplification process is used to differentiate the time difference between the cached state and cached miss, where this process is done using logical gates. The The logical gates and the time difference between each cache set and cache miss is measured by using low resolution timers with the help of this amplification technique. Also use it to create eviction sets using low resolution timers like JavaScript timers which are available in the browser, and this JavaScript timer consists of 0.1 milliseconds time difference between the cache hit and cache miss. Prime store attack is also implemented to attack the modular exponential implementation of the system, and it has proved that the sampling of this prime store attack takes place at a higher rate, which is almost 100 times faster than the normal clock rate. And thank you everyone.